Lesson 15, Transient Response of Second-Order Circuit. Section 15.2. Overdamped Response. If R over 2L squared is greater than 1 over LC, then the square root term is a real number. Alpha and beta denote the first and the second term of the roots respectively. P1 denotes negative alpha plus beta, and P2 denotes negative alpha minus beta. Let us assume that Q is given by this equation, where A1, A2, and B are constants. Substituting this equation for Q into the differential equation gives this long equation. Note that P1 and P2 are the roots of the characteristic equation. These two expressions in parentheses are 0. Then, the constant B is determined. These are the initial conditions. This is the assumed equation for Q. The constant B was determined to be CV. This is the derivative of Q. Applying the initial conditions results in simultaneous equations for A1 and A2. By solving these simultaneous equations, the constants A1 and A2 are determined. Thus, we obtain this equation for Q. And this equation for I. And these equations for VL, VC, and VR are derived. This is the waveform of VRLC. It has a step change from 0 to 2 volts at t equals 0. These are the calculated waveforms of VL, VR, and VC. The green line is VL, the blue line is VR, and the red line is VC. The parameters are L equals 10 millihenries, C equals 0.01 microfarads, and R equals 3 kiloohms. These parameters satisfy this inequality. At t equals 0, VL, VC and VR are calculated to be V, 0 and 0 volts respectively. The inductance opposes the step change of VRLC, and VL equals the source voltage V. We have these values for P1 and P2. The absolute value of P2 is approximately 7 times greater than the absolute value of P1. These waveforms represent exponential functions. The blue line corresponds to the function with coefficient P1, while the green line corresponds to the function with coefficient P2. The green line decays to 0 faster than the blue line. These coefficients determine the behaviors of VL, VC, and VR. The inductance voltage VL is described by this equation. In the bottom figure, the red line represents the waveform of VL. The blue line is the first term of VL. The green line corresponds to the second term with coefficient P2. During the initial transient response, this P2 term dominates. However, as time progresses, the influence of the P2 term diminishes rapidly, and eventually, the P1 term becomes dominant. The capacitance voltage VC is expressed by this equation. The red line represents the overall waveform of VC. The blue line corresponds to the P1 term, the dark green line represents the P2 term, and the light green line represents the term V. V is constant. The P2 term is initially small and rapidly diminishes. The P1 term dominates most of the time. This is the equation for VR. The red line represents the overall waveform of VR. The blue line and the green line represent the P1 and P2 terms respectively. The coefficient P2 determines the early behavior of VR, while P1 dominates the late behavior. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, Send emails to this address.